No, we're ready. We're excited to have Shane.
All right. Lizbeth, would you mind introducing our wonderful guest?
Absolutely. I'd like all of us to welcome our very special guest tonight, Shane St. Pierre. Wonderful, smart, witty. If you don't know him, I don't know where you've been, but he is awesome. I hang out in Ether Cosmology Discord at times, and I really appreciate the work that they're doing over there as far as the presentation, the research. It definitely cannot be said enough just how much you guys do over there in that space. And, I don't want to steal his thunder. I'd like Shane to take it away.
Hey, cool, great. Yo, what awesome honor to be here with you guys. Thank you for that wonderful glowing intro. I feel like I'm a famous wrestler in WWE and I just entered the stage. You know what I mean? You get this big build up. I should use an intro song next time, maybe. Maybe Mark will probably have that. Yeah, no,
Nacho Libre mask.
Yeah, right. Good to be here with you guys.
Yeah, and shout out to Glowbusters too. You guys are doing awesome over there.
Yeah, I didn't really know I'd be a permanent Glowbusters until recently. I thought I'd be like a guest host for a while, and then I just kind of became permanent. So yeah, I think that's probably happening too. Super fun, super pumped to have, the platform and be able to hold it up and get our reach out there a little bit further and really, do the science, man. You got to have people doing the science.
Right? Does Flat Earth have science on their side?
When I started, the claim was that we only have the science. We were the side exclusively using science, right? Has that changed at any point or?
I don't know. It's been a weird week. What do you think? We're here to help tell us.
Yeah, no, it hasn't changed. It's always exclusively been on our side. But I mean, to be fair, the argument has been ground measures flat, sky lends itself to the globe, right? In almost all aspects. That's how they made the model. Sun angles comprise the model. They refined it based on the parallel, tilted the whole world based on the assumption of their globularity and parallel sun rays. So to say it doesn't match would be silly, right? That's just something we got to work with.
Absolutely. Well, so on this show, when we have someone like yourself, we want to get to know a little bit of your backstory, and then we can dive into, I know you have some presentations that you're ready to go over and all sorts of, you can pretty much take the lead on what you think is important for our viewers. Obviously the Strange World crowd, we really admire your guys' hard work and we respect the science, but also we try to help things be a little bit easier to digest on this show. And that's where Mark can come into and break things down. So, but when did you get into Flat Earth and how did that go?
What a good story, man. It was so short a time ago. It feels like it was 2021. Well, I was still like a plebeian in the crowd, going to work, doing my thing, not caring, playing video games, doing just the absolute, slave mentality had me. And then let's see, COVID happened, right? And that whole interaction woke me up. And then 2022, I'm already trying to meet with Flat Earth Dave and Mark Sargent. I bet you don't remember Mark, but we did an interview. Let's see here. Ready? September 7th, 2022, with my first crew, who I just threw together specifically so I could talk to you guys, which was right after I did my first thing with Flat Earth Dave, which was back on, I think, June 13th of 2022. I pulled it up on my Odyssey today because I was like, when was that?
I knew you looked familiar.
Right? So,
I knew it.
So I had a first crew 2022. You were just doing interviews. I was trying to meet up with everybody, and you were the only one that said yes. Right? So you and I did an interview way back when, and you met my friends at the time who were, budding truthers on the path of, I don't think we were all flat earthers yet, but I certainly was at that point, right? So I was trying to bring them with me. I think you helped me do that. I think we went over the stars during that thing because I just went over the model, right? And I was trying to explain southern rotation to people.
Yeah.
So so that was super fun a couple years ago. Awesome. And then when I finally got to Discord is when the flat earth career kind of expanded because you meet a whole bunch of like-minded, capable, competent people who push you to excel and do things, right? So I tracked down Wisset. That's really what happened. I remember seeing flat earth stuff, and there's a point where you just kind of hit a ceiling and you're like, oh, and then you kind of watch on repeat, and then you see somebody just talk for 10 minutes and you're like, the hell did he just say? What was all that? Did he speak faster than me? What? Hold on, I gotta go back. Which eventually became, all right, I gotta meet this dude. Which eventually became, let's have conversations about all the stuff that we believe in for hours and hours, right? So then that expanded, you meet people of the same line, and if you don't see it, right, you build it and they will come. So at first there's your Discord community was it was split because I came right during the Great Schism, right? My first foray into the flat Earth community was the first big divide between ether and whatever the people who don't believe in ether accept, no motion or something. I don't even understand. But I remember there was a big divide between like Whitsitt and everyone else. And I remember how Whitsitt was the first to explain ether to me and how it worked and how it would replace certain phenomenon and how, we need to, if light isn't a wave and a particle, then it's a wave. Then you have an energetic background from which to wave in. And then you kind of follow from there the whole kind of framework of understanding of interpretation of framework for physics and motion and, the axial rotation into sidereal rotation and all of the arguments that kind of fell into that, I think came from that. And then, once we had ether cosmology, which was when we started delving into the ether rotation, proofs of etheric wind, GPS, satellites, all the arguments that I think we used to stay away from, we sort of embraced and refined and turned against the globers, right? So now we have GPS and satellites as arguments of motion using real inertial forces like Euler and Coriolis and centrifugal, which wouldn't be an impact if it was actually hurtling through space, right? You would account for those forces to keep satellites in orbit. You wouldn't account for a stationary, non-rotating Earth and a moving sidereal rotation exerting other, centrifugal rotations towards the center, right? Vortexual motions accounting for things to keep them in space. So once you delve into that, there's no reason to deny satellites in the sky anymore, right? Sure, they're on balloons, but the ones that aren't exclusively prove the Earth isn't moving. So, what do you got to say about that or whatever? And then there's, a bunch of other arguments we can go through that we like to have on the fly. So we delve into the research because when you're presented with a globe proof, right? Almost 99%, I haven't found one yet. I'm gonna say 100% of the time, if you look into it, not only is it not a globe proof, it's a flat Earth proof that's been like usurped and like subverted and turned against you with propaganda and scientism. If you get to the heart of it, it actually proves our position. And so we just love finding that out and showing that to people.
All right. Let Lizbeth see if she wants to get a question in here.
Since we're talking about, how you came into this and, there was a lot said when you're talking about like, oh, did I meet this guy and does he talk faster than me? I will say there are some times when I'm in ether cosmology and I'm just like, I need a dictionary. I need a thesaurus. I need to just go back to definitions, but I love it. I think it helps push beyond that basic understanding. But my question for you, Shane, is if it was just one, or were there multiple points that just stuck out to you that you're like, oh my gosh, like I have to dig into flat Earth more? Like, what was it for you that did it?
Nice.
Mm-hmm. You know the thing you're not supposed to look at that everyone shames you for looking at? It was the sky, right? The sky, literally, the thing that looks like the globe is what put me over. Because once you go through like the process and the awakening, right, as Owen Benjamin so nicely depicted on his series, Slow, that if anyone's seen that video. But once you go through that, I revisited observations that I made in the past of the sun, particularly, right? They're saying the giant sizes that it has, the motion that it's in, yet it gives you the appearance of a sun moving and coming and rising and setting. But really, you're rocketing and spinning and rocketing backwards faster than the speed of sound at the equator to give you the illusion of it doing that. And you're like, that doesn't make any sense. And the thing that really got me was like the sun in the clouds, the local sun observations, the planes with like the sun below the clouds. And I was just looking at that, like, I've never seen that. But if I had to think about it, what am I looking at? And what does that mean? Right? Like, what does that mean? So I remember bringing those observations to like the first Discord server, and they almost banned me immediately. Right? They were like, "That's retarded. You can't say all that." It's like, you asked for my opinion. What do you mean? Right? I was like, how can that be wrong? No, so that wasn't right. But then, so that's what eventually brought me to it. And what keeps me here, right, is the science of motion, the absolute bastardization that mainstream science has done to hide the evidence or lack thereof of motion of this place is astounding. It goes to so many levels. It's so deep. It encompasses different branches of science through mainstream, through history. If you've ever seen heliosorcery, it goes through like the Reformation, all through the hundreds of years of science being repressed and then turned around and then propagandized, weaponized, called learning against learning, right? Institutionalized learning of nonsense so that you can propagandize the whole world to get to where we are today. I mean, all of that is tied in emotion, I think, which is, I think, where we spend most of our time arguing. But yeah, you said that we use a dictionary. Listen, when I first heard Whitsitt, I had to look up so many words, and that was so exciting to me because I know a lot of words, right? I'm just going to say, like, I read books, I read papers. If I hear someone use a word I don't know, I'm like, what was that? What did he say? How did he use it? Well, hold on. What is that? What does that mean? Like, let me go look it up. So it's inspiring. And I think what you got to do is surround yourself with people that are smarter than you and then like everyone pushes each other to do better, and then you end up learning. And if you don't have that drive to learn, you stagnate, right? I don't think that's good for anyone.
Absolutely
So,
agreed.
yeah. So it's kind of interesting. I guess it's somewhat recent for being a flat earther, 21, 22. I mean, it's the same for me. It was basically 2022, kind of the year that my life was just flipped upside down, so to speak. But how did you first react to flat earth? Did it make you angry? Were you excited, curious? I mean, what emotions did you go through?
So the first time I was introduced, it was on a post. I remember the post specifically because it was such a crucial point, right? It had like 5 things on it that you thought were true that were bullshit. And it was like, I don't know if I can say it, but it was like virology is less than accurate or something, but it was more severe, right? The government isn't there to help you. Something in your medical interventions aren't safe and effective. And the last one on the list was, Earth is flat. And I was like, the last one's a joke, right? Obviously, because wait, hold on. The first 4 are totally true, though. Well, shit. I remember having that thought, like, oh no, if the 4 things I believe that I get last year, I didn't believe any of these 4 things, and there's probably a chance that the 5th thing is also true. So, like at the point when you realize you've been lied to about everything, it doesn't take much more to suspend that extra bit of disbelief to go into that for frame of reference, I think. So I remember thinking that, and then I remember like 6 months later, I was auto playing Flat Earth Dave interviews, and here I am. So
Right. It is crazy. It is Pandora's box when you're like, whoa, what have I gotten myself into? And you want to absorb as much information as possible. But it sounds like you had maybe a scientific background. Is there anything that you can tell us from your years in school or college, anything that plays into what you're doing now?
No, nothing at all, dude. I went to college. I was computer science and English. I did a classics minor, read a lot of books. I read a lot of history, did a lot of like Roman classics. So like when I critique the fake Greeks, I do it from opinion of reading the actual myth mixed with legend that bases their actual historicity and veracity on. So, I mean that's kind of a crazy thing. I did a lot of like gaming and programming. I wanted to be a game designer, but first job out of college was not that. It was just benefits and accounting stuff. And now I work with Excel and do regular accounting stuff. So really, nothing in that would lead you to believe where I ended up. But like I said, if it wasn't for that first awakening, I'd still be like a happy slave today with my financial debt slavery, living in the system that keeps everyone down, etc.
Okay. This might be, I mean, not too personal, but I feel like a lot of us share this experience, especially when we're first starting our journey. Was there a time when you were first, diving into this stuff that you felt a little bit of an ego death? Was there like a part of you that almost felt like mourning oh my gosh, should I just go back to the matrix? Should I just go back to being blue pilled? How far am I going to go down this rabbit hole,
Yeah, well, at that point, I was just head first in it, right? I hit like 4 other rabbit holes, like, oh my God, like this. I went from, is this safe to, is the government trying to kill me in like a week?
Yeah.
Oh, no. So, like,
Oh, I've been there.
right? So, like, after that, it really doesn't take much. But I mean, the things that I wanted to hang on to the most, right? When you're like, why do I can't give it up, was I think space time, like the whole science fiction background for called Star Wars videos, movies, games, No Man's Sky, space exploration, the canvas of wonderful blank creativity that they've spun that is like the multiversal travel, right? Where comic books come alive. Like that's so hard to get rid of and let go of, especially if it became part of your identity or your entertainment or whatever it was that is for so many people. And effectively, like that stuff became my prison, right? That's how I recognized it. I was like, wow, that is what kept me content in my placated little field. So I was like, all right, there was a good period where I couldn't enjoy video games anymore, where I couldn't do it. Only recently hanging out with the Ether Cause crew lightly gaming have I been to like recreationally enjoy that and be like, okay, I don't feel like this is actually keeping me tethered in a slave world. I'm actually just having fun, and then I can go back to doing what I was doing. So yeah.
It is true. That was the hardest part for me too, was giving up space, because I think for me, it was like the unknown was really exciting. I was kind of like, what's out there? Are we going to go explore? Who are we going to meet? And I really was kind of getting wrapped up in that mostly my entire childhood. And then kind of similar time as you, I was on this more of a spiritual journey going, well, maybe this place is designed, and is there any evidence of that? And what if we were created, and who is the creator? And it was kind of just an interesting journey from there leading us to today. So, but as far as kind of getting us on track with what you want to present today, do you think that flat Earth kind of gave you some more hope before we get started on the scientific side?
Yeah, dude. Flat Earth was originally like the fruit at the end of the giant hole, because you go through the conspiracy holes, and what you do is you go through waves of evil to the point where you're like, is there no end? Like, what is the point? This is all it? Is it all just black and death and terrible? And like, and then you're like, no, at the end it's okay, because you're actually created. All that stuff that you try to repress that you know is real, it's real, right? You're divine, you're special, you have connection with people. There's like science in resonance that connects people to the energy, to the etheric energy, to everything that gets tried to repress. There's a certain level of creativity that you have in this world, right? If you're constantly negative, bad things will happen. If you're constantly positive, good things will happen. You can call that what you will, right? But if you sort of adopt the persona and the effect, the perception that everything is going to be okay and that you're going to work out, typically that has a positive effect around you, right? So positive outlook, I think, is important. And I think that man, I forgot where I was going with that.
It's okay.
I
know, it's
looked
harder
down at
to-
Mark's face and I was like, I forget. Dude, I
No, that was
forget.
great. You have lots to say. I love it. It's really refreshing, actually, and you're doing awesome. So, Mark, Lizbeth, any questions? And before we kind of let him take the
Yeah, what games are you casually playing?
So PoE2 we picked up until
Yeah.
everyone stopped playing with me because I got too good. At first they were like, running me and making fun of me, but of course we get some time in and I know one wants to play. No, we play a lot of stuff. I think golf with friends, little fun games for multiplayer stuff.
Nice. Cool.
Used to be into games too, huh, Mark?
A little bit, yeah. Well,
yeah, I had more energy for games before Flat Earth, that's for sure.
Yeah.
But once I got into this, I was like, I have so much to learn. That's why I'm still curious and trying to learn as much as I can in the short amount of time that it's been. So just appreciate the hard work that you guys put into, because I think, obviously on the Globe side, they look at this as complete nonsense. But what gets us here is our own kind of research and breaking down the falsehoods of the globe model, meaning like if we're not in space, then where are we? If we're not spinning, then what's going on here? If we're not moving around the sun, what's holding everything together? And so it starts to open up and provide answers that, right now, a lot of that stuff's in question, but it's great to see that you have leaned into those arguments that usually might have turned either people away or haven't been explained yet, because that's okay too. I mean, most of this stuff has just been coming together through the internet, but people don't realize that the earth, if it's just always been level and stationary where we can see too far, and that people have been talking about this for hundreds of years, and that the ancient cultures all believe this. So people kind of skip over that detail, like, oh, this is like a new thing that this is happening. It's like, actually, no, you have the Zetetics that were saying this, that they didn't shy away from a possible 24-hour sun, and none of these experiments from TFE can put the earth back into space if it's really not there. So for you, kind of, where's your mind gone since it's gotten so much attention the past year?
Flat Earth or the final experiment?
Just both. I mean,
do you think Flat Earth has gotten more attention in the last year then?
I don't know about more attention, but it seems like this TFE and within the community is definitely causing a lot of discussion.
Yeah, dude, that had the most derision that more than I ever thought I would see from it. When I remember when it first was coming along and I was just ignoring it, and I was like, you know what it feels like is a giant momentum sink when we're doing so well, we're wrecking them, we have all these arguments, everyone's cohesive, no one's tearing each other down, and they just want to stop that. So every time someone comes in a space and talks about, what do you guys think about the final experiment? It's like the whole momentum drives, everyone stops, you start bickering, there's a whole nonsense drama starts coming up, and that, if not the goal, is the absolute intended side effect, which is the whole point of to kill the momentum. But when they came back, I did not expect so many people to just dismiss it, to adopt a scientific logical framework of it cannot possibly be, so therefore it isn't. Right? That's not the group of people that I joined with. That's not who was trying to find out the truth. That's not the group of people that awoke to the first thing that got me in the truth community in the first place. So,
right.
I think that the quote other experiments they did there are interesting. I'd like to see some of the data from some of the stuff. I know that one of the ones they claimed to have shown or done was converging longitudinal measurements. And personally, when you're trying to measure a conceptual line in the sky based off of the sky on the ground, I'd like to see the method. I'm not sure if they published the method but without referring to GPS or this, the actual graticule, the spherical coordinate system that's the backbone of maps, or elevation angles to the stars. I don't have any idea how you'd confirm a longitudinal convergence in the south. Because I mean, the sky symmetry is what they're going on, and of course, the sky would be symmetrical north to south. That's again how we started with the globe model, as we said at the beginning. So to confirm that the ground is matching that convergence would be interesting. I'm not sure I've seen anything about that. Like the weight differential is interesting, but that's kind of easy to explain, especially for an etheric framework. I don't know if you guys have a gravity argument, but our prevailing theory is the electrostatic downward acceleration, right, where Earth's charge creates the downward vector, and then buoyancy, density, viscosity do the work to force everything down. So in that framework, electrostatic variation by latitude would easily be, determined as a variation by that. I mean, if you just go into little g varying by a height, a function in time, you can figure that out. So that's not really a dynamic cause of anything. So the weight change differential is kind of easy to explain within the etheric model with the kinematic equivalence. And what are the other ones? Honestly, 24-hour sun and moon, we don't really have a solid answer for that, right? That one's still up in the air. We have hypotheses, we have working models, we have proof of concepts, but I don't think we have a solid refining answer that beats beneath your feet.
Agreed.
Mm-hmm.
But the other experiments, I think they're just fluff trying to throw on the cake. I think all of that can be scientifically and logically refuted. I think the only thing they have is that observation, which, to be fair, we knew they had before, right? And if we're talking physics and the observations of celestial mechanics, you have kinematics, right? Things, why they move. You can see how they're moving. Then you have dynamics, the reason why they move. And, the scientific prevailing mainstream theory has been playing with dynamics. They purport to know all the reasons for everything moving in the sky, right? They claim it's mass attracting mass, but we don't have a compelling dynamic replacement for that. But we never have, right? We never know why the sun is up, what keeps it up, what keeps it circling. Those aren't questions that any flat earther has really had an answer for above, speculation of electromagnetic gradients and, cold fusion that would keep it. Like we don't have any dynamic cause. All we do have is empirical, right? So observations, kinematic observations of where we see the sun and things like that. Oh, that was the other thing. They observed a southwestern sunset, right? The sunrise angles in the south. They claim that as proof, but we addressed that beforehand, right? Unless you put like a spherical limit over the observer, then none of the angles in the sky would make up for anything. So, I mean, if you can't see all of the sky, right? And I think if you look out, you can see that's true. The logical deduction would be then that there's a limit to your vision. And then, geometrically, if that limit is the same in every direction, the shape that would make over you would be a dome, right? So you have a geometrically limiting limit of vision that you can logically deduce is there. And then once you have that, everything in the sky kind of makes sense along with a flat earth in my mind.
Absolutely. Lizbeth or Mark, any questions?
No, he's doing great so far.
Yeah, I know. Wealth of information. A lot of these terms, though, kind of can maybe go in one ear and out the other for some of our viewers. No offense to anyone out there if that's not the case. Maybe I could just speak for myself. When it comes to maybe, the downward vector or downward electrical bias, I mean, what would be the best way to describe what you're saying there?
Yeah, so that's one of my favorite arguments, actually. And I think Zach, our buddy at Globebush's Good Times for All, has an excellent video out. And if you Google it, I think it's called Why Incoherent Electrostatic Downward Acceleration Causes the Downward Bias. It's a very long title, but it's very specific. And I know that it's out there. And I know that when I first watched that video, I watched it over and over again. I transcribed it to text. I read it, I had it summarized. I used it for all sorts of stuff. That was kind of the basis for it. But the best way to understand that is that there is a downward vector, meaning that something is producing a variation to attract more downward than any other direction. Now, it doesn't have to be a huge force. It's very slight, right? It's an electrostatic gradient caused by the Earth's charge and the gradient with the atmosphere. So that downward vector is the only thing that is causing things to go down. And when you change that vector, or when you overpower gravity, or when you overpower the downward force, it's like a Van der Graaf generator. You actually use the charge to change the polarity, and you make things go up. So you've actually affected your hypothesis that electrostatics is a downward vector by changing the direction of that vector in a controlled environment, meaning you can make things like human hair feathers, wood chips, they can from go down to go up. And Witsit did that in the last, I think, whatever the flat Earth documentary video from
Level
Kibler
with
was. Yeah, thank you. Level with me. Definitely, they show that in all of them, right? So that's the best way to understand that, is that that's a experiment that shows our dynamic cause of the downward gradient or acceleration being electrostatic in nature, and then being able to manipulate that to show and change the vector, which is what you would be able to do if you had a correct theory.
Well, and that's why I think it's so important to kind of touch on, because the globe model relies on gravity, which again has two options, right? You have mass attracting mass, or the warping and bending of space-time. And a lot of people don't really understand what that really means. I mean, if I try to explain it to maybe a relative or a friend who doesn't really have a science background and, cosmology and all these different, reasons that the globe technically, quote unquote, works. When you get to the flat side and you're like, look, we have density buoyancy and this place is electric, then it starts to kind of replace this necessity for gravity to be something that is being caused by the sun or the bending of space-time, which means the fabric, the blackness between us and the sun, that we're somehow caught in that bend and that's causing us to be pulled towards it. But what I find kind of fascinating, and it has kept me on this side, because again, for me, the flat side, it's not so much what is the floor, it's where is the earth. I mean, that's really where that's what got me here. That's why I'm staying here, because I think that we are on the better path for trying to figure out what is the earth, who put us here. And hey, Mark just changed my thing. Oh my God, that's funny. Okay, change it back. You're making me lose my train of thought now. You're so funny. But it's because obviously the final experiment is relying on the fact that they think that the earth is in space. And if we're not really in space, then where's the earth? If the earth is not there, then there's other things going on here that maybe the powers that be understand how our world works, and they've had a long time to come up with a quote unquote model that can predict. Because let's be real, if we're in space and we're a wobbling, tilted, spinning space ball, it's pretty consistent, right? That spin is very reliable. That trajectory is very reliable. The course through the solar system is very reliable, that they were able to make predictions based off of it, because it does work. So it's like a fine-tuned, well-oiled machine here, the earth. And when you get to the flat side, it's more like looking at the earth like a clock system. You have the sun and the moon, the big hand, the small hand of maybe a clock, and then you have the stars that are kind of progressing around us, almost like they're the seconds on your watch. And so that's where my mind immediately jumped to. It's like whatever we saw in the sky doesn't necessarily prove that we're back in space. And it's so important that I try to get this thought out, because they were able to take what's working here and create something around that. And that that to me is why there's so much deception. And it's we shouldn't be fighting with each other, globe side or flat side, when we both agree that how is this system so stable unless something put it here, and unless something had this in mind and gave us that. I mean, they take it, the Big Bang just takes all of this and puts it together like, oh, that was a big happy accident, and it just happens to be working so predictably. It just happens to be exactly they tell us that's the truth. And it's when you get to this side, like, actually, it's a lot more complicated than that, and it's an intelligent designer had their handiwork. So it's not necessarily a question, but that's my statement.
I agree. It's a powerful realization.
Good. Well done.
Yeah, because like when you look at the lunar cycles, I mean, before we had actual clocks, I mean, people back in the day could be looking up at the sky and they could kind of figure out what time it is. You look at the sun, it tells you what hour it is. You look at the moon, you can figure out what day it is. And you're looking at the constellations, going to tell you what month we're in. I think that's by design. I don't think that's a big accident. And that it's, if you know that that's what, if you're trying to deceive, you can take what's working so well and you can create something around that. And I literally think that's what's happened. I'm not afraid to say that. And I kind of stand by that. And it's in line with the scriptures for me, which just will always give me a better sense of what could be our reality and what I believe is our reality. And so, it's nice to see, though, Shane, that you guys over there that dive into the more scientific aspect of things can help break down what our world is really doing and provide options versus what the globe side is giving us, which again is a big leap of faith. I mean, nobody can show us that, hey, you're actually in space, that mass is attracting mass, that you're going around the sun. No one can prove that. And TFE definitely did not, with all due respect to TFE. So,
yeah. Man, not to mention, sorry, let me chime in just for a second, not to mention the three body problem, which it's tough to bring up to people because it's tough to explain. which again, once you put 3 bodies in an, an empty space, even the best supercomputer cannot predict the modeling. So what do you do with the solar system? And what if the solar system is flying sideways and all the other things that go with it? I mean, my favorite thing, by the way, is if the solar system is flying sideways at 500,000 miles an hour, and we know there's these null points supposedly between like Earth and Mars and Jupiter and stuff like that, where there supposedly is no gravity, there's no pull. Whatever's flying through there would be just lost, no different than dropping a golf ball out of a high-speed car. The golf ball is going to stay with you for a short while, but then it's gone. Your car's gone. Golf ball's back that way. So how are all our probes doing what they're doing when we're flying sideways at 500,000 miles an hour? Most of the public doesn't know that. So sorry, it was just in my head. Don't want to take away from the guest. Shane, where did we leave off with you?
No, let's do the 3-body problem. How do they solve it? They simplify it to extreme and then replicate a simplified series of solutions and pretend that was the problem the whole time. So how do you build the solar system? Well, you can't do Mars, Earth, and the sun. So what do? Earth and the sun, Mars and the sun, Venus and the sun, Jupiter and the sun. You solve those simplified series. You know how those 2 bodies predict. You put those together in a nice, pretty picture. Boom, I've mathematically created the solar system, right? Through a mathematical, cosmological, philosophical framework of invariant scaling and, what's really one of the Copernican principle, right? The desire that you philosophically frame your science that humans are not at the center, that we were created, and that everything is a cosmic fart, right? That's pretty much the Copernican principle.
Right. Because if everybody found out tomorrow that we were at the center of creation, it would open up the conversation of then who put it here. And I do think that that's part of the reason why this world is dealing with this problem as is. It's hiding where we are. That's why it's so important that we kind of get away from just worrying about, the floor. I think the floor it's great to know. It's so important, but it's more important about like who put it here and where. Why the Earth? And when you're in the globe model, it's just a big random happy accident. But again, like I said, it's just so much has to be working together for this accident to be as beautiful and special as it is. And I'm just not ready to discount that or turn my back on that. So it doesn't matter how I look or we look when we're the ones questioning things and knowing that there's a lot more going on here than meets the eye.
You mentioned eclipses, man. Eclipses are one of my favorite things. I remember I spite learned about on eclipses. So what happened was somebody made a comment that was like, flat earthers don't know about eclipses. And I was like, I'm gonna go learn everything. I'm gonna go make a spreadsheet of every eclipse prediction that's ever happened. And I'm gonna pivot table it out and I'm gonna aggregate it and play with it until I learn some stuff. So I went and learned a whole bunch about eclipses. And then I don't know if you guys know, but one of the Globers bet $10,000 I couldn't predict one, and I did it in like 2 minutes. And the dude definitely paid me $10,000 bet, funded all of flat Earth for being arrogant or whatever, making a statement, but then sticking to his bet. So I mean, the eclipse cycle is actually it's twofold, super interesting because you were talking about the dynamic cause of everything, and this is one that they don't have a dynamic cause. So in physics, dynamics is they know why it's moving. In this case, they're using, say, Newton's laws and gravity and mass attracting mass to predict eclipses. 100% zero to do with any eclipses. All that has to do with eclipses is observations from a geocentric viewpoint. So you have sun azimuth, sun elevation, day, time, direction, bearing, right? And you have length of event and various kind of categorizations, but nothing is heliocentric about it. I used to challenge all the Globers I could about eclipses because they just start saying stuff that they think they've heard. Well, obviously geocentric, like obviously NASA, no, none of that. NASA has nothing to do with it. It's Fred Espenak, an independent researcher, journalist who put together all the eclipse cycle stuff from all the ancient civilizations, really just linked together different Soros cycles, right? Which is then they do this lunar cycle compilation. If you look into eclipse cycles based on the periodicity of the lunar periodicities, there's a couple different things, like it's perigee and apogee, so it's point and its ellipse, its brightness and its proximity to the sun. When those line up, right, it does this 18-year, 10-day, 11-hour cycle that repeats and repeats and repeats. But the thing that they don't tell you is that that's a piece of a smaller, that little cycle is a piece of a bigger cycle, that when it repeats around the zodiac every 18 and a half years, the same eclipse will happen over and over again, slightly different variant until it comes back around, forms a bigger chain of like a greater astronomical year, 651 years. And then you have some of those that stick together. This is what they use to build what's known the eclipse chronometer, where they have dated historical records and times based on unwinding the cycles of the sky. So you said the cycles of the sky are what keeps it all going. It's absolutely based on old school knowledge, nothing to do with NASA, nothing to do with new science. And moreover, if you understand it correctly, you can not only date and link historical accuracy to the Bible, you can link, biblical events, times, things like the flood. You can go back one, and then what actually ends up happening is you verify a chronologically young Earth that ends up being something like less than 8,000 years old, depending on the cycle. So you can use the eclipse cycle to date the Earth. That's pretty cool.
That's very interesting, actually. Okay, so you were able to predict eclipses. What other arguments do you get that from the globe side that you find that flat Earth could use some help of just having more knowledge of what we really know on our side?
Maps, dude. Maps. People get crushed with maps all the time. People misunderstand the tool of a map projection and where it comes from. Man, that's a tough one. So I recently tried to debate Globers on it, but nobody would debate me except for Craig FTFE, who showed up to just make it a festival, and then he immediately adopted my position, which means it's the correct position and nobody's admitted it, right? And they still pretend that it's different. But in reality, maps are just projected coordinate systems. The only coordinate system that is projected is the geographic long lat. So latitude and longitude, inherently based on flat Earth elevation angles, however, are prescribed to a spherical coordinate system. Like long lat is spherical. That is based on the observation of a hemisphere for the observer, and they mathematically, use spherical trigonometry to predict things that are outside of your view. So longitude and latitude is a spherical coordinate system. Does it mean that the Earth is flat? Absolutely not. It specifically is tied to the celestial angles. So it means you view the Earth in a hemisphere. That's all that coordinate system is based on. They use it to confirm the hemisphere. When you go confirm long lat, you're lining up your latitude to see where you are on the Earth. Otherwise, if you don't know the land, you have no frame of reference on a place that's 73% water, right? So when we get to maps, we're projecting a spherical graticule, and we have various distortions on the maps. If you look at something like the Gleason's map, the distortion would be, say, southern extremities get wider according to the distortion matrix, right? So that doesn't mean that in reality the world is that big. Does it mean in reality Australia is 3 times as big? Absolutely not. Like it's portraying a spherical coordinate system. If you bring it back to the ancients, the astrolabe was the first thing to do this. It did it by projecting the spherical sky, which they saw, onto a flat plane disk for the local environment, right? It's the first known version of stereographic projection downward. They would project what is the spherical sky through like the hole on the planisphere, and then they would lay out the celestial arc in front of you and that's how they get all the known star positions. So the ancients knew that it was called cosmography because they would link the stars to the Earth because you couldn't do it otherwise. And tools like the astrolabe would show you how the spherical coordinate system gets outlaid to the Earth. Only nowadays do people think that all inherent map distortions are because Earth is a sphere, not because the coordinate system that they're projecting is a sphere. So it's what the maps argument should be is nullified. It's actually model and non-exclusive, right? It doesn't prove spherical or flat either way. Everything to do with maps is model and exclusive. But I think that's a really big one.
Yeah, super interesting. Guys, anything come to mind?
No. I'm waiting for him to say keywords that'll trigger me, and then I'll
Okay.
I'll
Well,
freaking
I mean,
fly.
I have a question then. So using the stars for navigation, and honestly, you're gonna have to help me with this because I don't have the full background information. If the Earth is technically a hemisphere where there is a dome and we're kind of underneath it, and the Earth, the water is seeking level and it's not rotating, it's not moving. Technically, if we were on a ball, wouldn't that have to be maybe kind of that would just add a mix to how we navigate that wouldn't be in line with how we actually do circumnavigation on the Earth? I mean, what can you tell us about that aspect of navigation? Like, what do you find interesting that got when you came to the flat side?
So they say that celestial navigation only works on a globe, and they say that celestial navigation only works on a flat plane, right? So what really happens is that celestial navigation works because they've combined the coordinate system. What they've done is they've mirrored the geographic Earth, the spherical Earth, also known as the graticule. The longitude latitude system is a mirror of the celestial system. So what you have is a right ascension declination sort of grid line for viewing stars, and what you have is a 1-for-1 model of that system called the spherical Earth. The reason celestial navigation works is because for every point on the Earth, there is a point in the sky at a certain time that corresponds with it specifically and exclusively, right? So this is known as the ground position. So you have a ground position of a star that's specifically tied to one point on the spherical Earth. So the way that they would do that, right? The Ptolemy, the first one to do it, going back to our fake Greek lesson, wrote a book called Geographia, who he actually stole from a Greek named Strabo, who was literally better known as, it's called the terrestrial and celestial spheres. It's the basis for all cosmography, geography, cartography, and map taking. And all he said was, to even understand this, you have to accept the two-sphere model, that there is the terrestrial and celestial sphere. So the reason celestial navigation works is these two models have been contrived. That's why you have a ground position linked to a star, and that's how you can navigate based on where it is in the sky. How that would differentiate models, honestly, the interesting thing about it is I think it would be identical either way. It's one of those things where you wouldn't know from within it which model it is, because a flat plane with a hemispherical sky or a infinitesimally identical curving sphere that looks flat, right, with the same hemispherical sky, would be inconclusive from within it. And I think that's how they got away with it. But the celestial navigation, I think, is one of my favorite things. If you look into the board of longitude from like the 1700s, the story there is super interesting, right? They had Isaac Newton putting forth that, no one could create a timing device that would be able to tell longitude at sea. They put a decree that, for the Royal Society, they put out like 500 gold pieces for anyone who could navigate by the southern extremist longitude to a degree of half a mile. There's this whole thing where they were trying to go to the Southern Observatory to go map longitude. But the funny thing is, they decided in 1712 that everyone needed a spherical coordinate system in longitude, and that they needed to eat like Greenwich meridian to go through their observatory. But before that, and for thousands of years, everybody was navigating on the ocean fine, right? They had methods of determining longitude. They had, first of all, latitude is the only determining factor, right? Mostly where you're going to go. And then they had straight shotting, and they had lunar transit method, where they time how fast the moon would take past the star. They convert that to a form of longitude. They'd get 15 miles per degree. They'd convert that themselves. They used Jupiter's moon as a timing piece. They used all sorts of celestial phenomenon and just latitude. So did anyone need longitude to navigate? Absolutely not. Is the spherical Earth required for celestial navigation? Not throughout all of history, and not now. So
Damn. So yeah, I mean, there's a lot of information, and my mind just wants to help break down the things that maybe kind of go over somebody's head or my head. But yeah, I guess if you know where the stars are going to be, you're saying that's what can help figure out where your destination is. Is that what you're saying?
Absolutely, right. That's the well-known thing. The only thing that was in disagreement or contention was, the 69 miles per degree. And in old school is based on a nautical mile, which is just the unit of a circle, which is, a specific arc length. They converted it now to be spherical in nature, right? An arc length along the equatorial meridian. But all I'm saying is the amount that the stars would process for how far you'd go laterally on the surface was in contention. In Rome, it was like 50 Roman miles, which is like paces. It pretty much varied between like 61 and 81 miles of today. So they don't. The reason I'm saying that is because it varies by latitude. And if you were taking an average of people all over the Earth, not taking into account that it varies by latitude, you would get differing numbers all over Earth. People would just be averaging it out. Like, how long is your 69 miles? Well, it's 48 over here. Well, I got 62 and I went over here. Well, that's weird. I don't know what it is. So they would try to figure out that main basis. But that whole metric is actually determined by, nowadays, they tied it to the spherical coordinate system. This is the funniest part. They decreed that the meter, meaning, the nautical mile to the metric system, would be 1/10 millionth of a terrestrial meridian, which is the length of a theoretical North Pole to the equator, can only exist on a sphere. That's a geodesic arc on a sphere, right, from the North Pole to the equator. So they decreed that the meter would be 1/10 millionth of that. If you do 6218, which is 90 degrees of separation, 90 degrees of latitude times 69 miles per degree, then you get something like 6,218 miles between the North Pole and the equator. 1/10 millionth of that is 1.0007. So they literally equated the unit of metric measurement to a ratio of the spherical system itself. And I think Alan talks about that all the time, but it's a really big, important point.
Groovy.
All right.
We are coming up to our one and only break, which we take for like 3 or 4 minutes. You guys can do whatever you want. So what's going to happen is you're going to get shoved to the left side of the screen. Or
Meet them before the concert or after?
Karen B.
at the concert.
Oh my God, no. Sweet. I'm excited. I know. Did you meet him before the concert or after? Well, you saw this before.
I met him a day before. I was lucky, and then because he had a day off, and usually the day off they don't do anything. So he's like, yeah, sweet. So we just hung out till we went to dinner, and I drove him down to a restaurant in Seattle, and we ate and came back and caught a boat home.
I'm super excited. Having him on the show was great because I really got to kind of hear more of his thought process with everything with flat Earth and what kept him here, and what kind of he's very observant, and he has a lot of great insights. It was just super cool too.
He was dropping knowledge bombs on the girls, on the salon girls, on the island girls. He was absolutely hating them. You know, the whole. He's like, when you wake up in the morning, what you see lies. It's all deception. It's like, whatever you think is that you got to start from there, man. And then, it's like, don't forget, we're all in this together. Very, very deep thinker.
Yeah.
Stefan. So I like him. I like him. He's fun. You're gonna have a blast. All right. So Shane, also a deep thinker, who's also what do you call that? What's the big grid behind you? I haven't seen that one yet.
I have no idea. Generic visualization 13 or whatever.
You didn't come up with something special for the show? How dare you? How dare you, sir?
Oh, I thought that was the warping and bending of space-time.
I know. I thought
actually doing geodesic arcs in the background. Yeah, there it is. That's gravity cause right there. The dynamic cause of everything.
And by the way, that sunlight back, I know we're not doing headlines today, but that sun behind your head looks more real than the ghost probe that supposedly landed on the moon like 2 days ago. You guys haven't seen that. You should look it up. The sun shot. It's a still image. It's not even video. And it's just this still image, and it's just this glare. It's a lens flare. That's nice. It's this lens flare, and it's horrible. It's absolutely freaking horrible. It's like, really, because in 1969 we could do 10 frames of color video per second from a dish that was running off a car battery. 2025, nothing. We got nothing. And there's no stars in space. Trolls in the chat, please tell me why every single probe, every single rocket, there are no stars in space. Please tell me, because it was exposure settings back in 1969. You don't have any excuse now. Sorry, my blood pressure's up. All right. Anyway, Shane, what do you want to do?
I mean, did you want to go over some more TFE stuff, DJ Curious, or when do you thrust to the theodolite? Because I know Lizbeth has been chomping at it.
Yeah, Lizbeth's excited for the celestial theodolite. Shout out to.
Oh yeah. By the way, somebody said, make sure we pronounce it theodolite, not
theodolite, not theodolite.
And I did just want to say too, we are actually having Dr. Mike Heffron come to Flat Earth Gang on Clubhouse this Thursday. I already told you, DJ and Mark, if you guys want to stop by. Shane, obviously, you already know. And he's going to be doing an open discussion. So it's, open for questions and so forth. We allow everyone to come on stage and speak. Just be respectful and be respectful of the mods, or you will be sent to the gulag.
All right, that sounds great. Hey, back to Shane really quick. That footage that was behind you of the 24-hour sun, was that from TFE?
Yeah, that was the 360 footage that we had.
Was it?
We helped Witsit put it up, so I got a really good close look at it, all of it. We were there when we caused that mountain glitch for everything, when we figured out how to stick 360 footage together, because nobody knew how to do that. We kind of screwed that up a little bit. We were there. It's we got a good look at it, and that's what that's from. That is the full 360 cam.
Yeah, there was a lot of data to kind of stitch together, right? I remember when he was going through it, trying to download it, and it was taking 14 hours. Poor guy, he was not getting any sleep. People are attacking him. It was just crazy, like you were saying. We weren't expecting that. But I do want to kind of touch on, just while the topic is hot, what do you think are some viable possibilities of the explanation for the 24-hour sun?
Well, listen.
The cat had a reason. What did the cat say? It's God.
Listen. So, like Joe Hanby's got a model for proof of concept for basic reflection. However, if you go deeper into flat Earth, electromagnetic, crazier theory, or some of the occult theories, you get into something called the Black Sun model. I don't know if anyone's ever heard of that. That is kind of the proponent of flat Earth model that I believe in, where there's something underneath the Earth causing both the manifestation of the sun and the moon, right? So you're already into non-physical sun and moon. Something underneath it is causing it. For moon phases and a regular solar activity, you have this destructive and destructive interference between the sun and the moon, right? Enoch has it as the greater and lesser light. The lesser light can't illuminate next to the greater light. What that really means is that the moon can't be luminous next to the sun. It's literally physically prohibited from putting out light, which is a form of destructive wave interference. So literally when the cones intersect from the black sun underneath, I think it does some sort of destructive, let's call it even holographic, not holographic, magnetic polarization effect, which would give a destructive interference, which would make it seem like it's not there, right? Which gives the appearance of a shadow. So that's the background from my whole understanding of framework for where I'm coming from, for what I think the sun and the moon are in the first place. And then with that observation, right, you get some wild speculation for everything in the sky is personal to you, right? That's a basic statement, but it has some gravitas to it, right? Some weight behind it, meaning that beyond the fact that everything you see is apparent, beyond the fact that nothing is in a quote true geographic position that we could reference to each other, everything in the sky is personal to you, right? The sun specifically, if you look back at the flat Earth, I think Effie Core did a video trying to model specific sun azimuths and angles for one location all over Earth. They ran it through a supercomputer. They came out with, it broke the supercomputer. There was too much ray tracing was going on. The end result was that it formed this toroidal manifestation around the flat Earth that looked kind of like this, like a bowl, and that would be the path of the sun mapped out for one observer everywhere over here. So literally, it appears to be everywhere for each observer. The other important piece of observational evidence for this is if you go to like a lake or like a beach and you stand next to your friend and the sun's out, you'll see the specular reflection of that sunbeam from the sun to your feet only. You won't see it go to your friend's feet. You'll see it go to your feet. If you ask your friend, he'll see the same beam of light go from that sun to his feet. You won't see it go to his feet. And then meaning that crepuscular ray is personal to your perspective. Only you see that ray. Nobody else sees that ray. So tying all that together, trying to understand what's happening in the south. Well, that's I think that wherever you are on the earth, you can see the sun, right? Depending on the time of year. The same thing is true with the sky and the celestial. That's why all the ancient megalith structures are aligned to say the zodiac and Orion specifically, because those stars are visible from anywhere over Earth. Same principle with the sky in the daytime. The sun always circles around the observer depending on the latitude, right? So only in the extreme south then would you not have the sun circle around you. Something else that Whitson said when he was down there was that it feels like foreboding when you're down there, that it's like the end. He said he got that weird feeling. I mean, that's not scientific evidence, but I took that into account to consider if before I was entertaining, more land out there that, you could just sneak out past the ice barrier and get to the next bubble or whatever. I used to entertain that theory. I no longer do because of this, right? I think that evidence, meaning there's nothing else past there. If you were to go out there, the sun wouldn't follow you past a certain point. So what's my dynamic explanation for the 24-hour sun? Is that it's a non-physical manifestation of a personal source projection that is the sun.
Right.
Well, and that's where people get a little kind of either confused or they have a issue with it because like, well, no, this is a physical realm. What are you talking about? It can't be an apparent position, even though apparently on the globe side, they do kind of adhere to that as well. But Lizbeth, since you were there, I have another question.
Mhm.
How did the temperature of the sun feel? Did it feel like the actual sun or did it feel weaker? I mean, it's hard to say, right? But any thoughts on that?
Well, right, it's cold, right? However,
Right.
what I found very interesting, and we all were commenting on it, and this is part of the Google Drive too. Austin has access to that, Jaron has had access to that, and so forth, and a few other people as well. And again, like it's not hidden information; anyone can have access to it. It's a Google Drive. It's what I was able to take, and thanks to Taylor for suggesting it because Austin had the thermal gun, so we were taking the temperature readings, and literally all it is just okay, what time is it now? Okay, 1 p.m. local time, 2 p.m. local time. Let me take a screenshot of my phone of where it says, the temperature. However, once we got to say 2 a.m., 3 a.m. local time, we went from 16, 17 degrees, right, at high noon or, at the highest point, so forth, to now at 2, 3 a.m., we're at 6 degrees, 7 degrees. And you felt it. You really felt the difference. Like we were all commenting on it, like it is significantly colder. I remember going outside at 3 a.m. local time, and I wanted to do say a quick FaceTime call with some friends, because they hadn't heard from me in a few hours and so forth. And it was freezing out there. I remember McToon was doing his live stream at that point, and I just remember just feeling super cold. So and it was like that every day. Like once it got to those wee hours of that local time, it was a very significant temperature drop, and I haven't heard a great explanation for it. Now, I'm not saying that I have one, but that's definitely something that piqued my interest as far as why is the temperature so drastic, you know, when the sun has been in the sky the whole entire time. It's been reflecting on this white shiny surface. So like why the difference, right? Like when we're here and the sun goes down and the temperature drops, that makes sense, right? But when you're in a place like that, I've never been to that type of climate. I've never experienced, you know, constant daylight or the sun in the sky the whole entire time. So to me, it's a head scratcher for me, you know. Like again, if anyone has an explanation, globe side, flat side, like I'd love to hear it. But those were one of the things that, you know, very much stuck out to me when it was as far as time, you know, the time and then the temperature.
The
Well,
tough thing
I
is
guess
that
my mind
Earth
goes.
ball.
Go ahead.
I was gonna say Earth ball is hard to compete with. Earth ball, sun beneath my feet is the easiest explanation. It's hard to compete with that.
Right. I mean, but it's interesting because at least on the flat side, we can brainstorm and talk about other possibilities, right? So the Hamdi model kind of shows that the sun might have a physical location on one point on the earth, but then it's causing either refraction or a reflection on the opposite side of the earth due to dome optics. And if that were the case, is there any evidence that maybe rules this out if that's the optics are what maybe you guys experienced in Antarctica was not the physical sun, but it was a reflection of the sun, which would mean that it's weaker, and that could be why. And I feel free to shoot this down at any time, guys. But it was compressed at one point, as if the sun was moving, maybe on a physical point on the Earth further away, and also kind of in line with Crow 777, who I believe has maybe evidence of what appears to be two suns. It could be the physical and a reflection, right? I mean, is there anything that on our side that rules that out immediately, according to what you guys?
I just would see when the transition from real to reflection would happen, right? That'd be integral to that hypothesis. Because from all observers, it never transitions, right? As far as I can tell.
Yeah, that part is interesting, but how it's until the modern era would be really hard to witness that, right? I mean, you would have to have some sort of camera technology to record it, which again has just been past couple generations to really figure this out. So that's why I don't think that we can just rule it out completely and it defaults back to a globe in space. I mean, maybe things work on a spherical model, but doesn't mean that it's back in the heliocentric model. So it's important to just kind of touch on these things, and maybe off air is better, just because obviously the globe side wants to use this as, hey, you guys don't know, and that's like, that's okay. We're not claiming to know how everything works. We're again on the side of curiosity and exploration, and going with there's things that work on the globe model, there's things that work on a flat theory, and then there's things that work on both, and there's things that only work on one or the other. And so finding out those things that only work on the flat side is important to kind of focus on, and ruling out those other things that don't automatically default back to a globe model, right? I mean, that's where I wish this could have gone as a collective. It's just saying, hey, here's what's working over that we know, and here's what's not, and then let's kind of still investigate, because something is fishy.
Well, don't forget, you're trying to replace the explanation of everything, right? They know with certainty that once there was nothing, then there was everything. Then gas coalesced into big planets, which got round because of gravity, which attracted more mass, which began burning, which then became life, which spontaneously came from nothing, which burned iron, helium, hydrogen, gas, argon until it burned, and then exploded, and then that became more of you, right? That's the theory that we're trying to replace the dynamic cause of everything, which, you know, that's preposterous. That's a crazy theory. I don't think that we have any sort of semblance of a theory besides, hey, we were created and put here. So, I mean...
Right. And something's working, and it's figuring out how it's working, and somebody came up with a good reason or a good model, but is it actually the truth? That's what the flat side represents to me.
And Shane, with your sorry, just a quick interject. With your model, you were already accounting for the 24-hour sun prior to this whole TFE thing, correct?
Based on, empirical observation and timeanddate.com data, right? So sun azimuth and elevation angles would lead you to believe that would happen, right? Because when they saw, when you guys saw in Buenos Aires, when you saw a southward facing sunset, right, when it appeared to go circle around, to go in the other direction, that would have been an indicator that followed that to completion, that, you know, inverse antarc would eventually result in the complete rotation, right? The same is true for the north. So I don't know why we would assume that it would look like all signs would point to it, but then at some mysterious point between here and 80 degrees south, something happened where it didn't happen, and then it would set. Like, I don't know if that was the position, but my position was that maybe timeanddate.com data was, like, you know, falsified, and that the symmetrical nature of the apparent sunrise and sunset and twilight and all that time, that wouldn't appear to be as symmetrical as it was. But as soon as you guys made the observation, I was like, oh, well, so it is exactly as it was appeared to be, right? So the model definitely predicted it, but only empirically, meaning only based on observations and based on measurements, based on things you see. So.
Well, you touched on maps. If you don't mind just giving us a recap for those just joining us, what is it about maps that the flat side should know?
Right. So maps are my favorite target, my favorite topic, I think, really. They're model independent. So maps don't prove a globe, they don't prove flat Earth. They are projected coordinate systems, and the coordinate system is spherical. So the graticule, which is represented by longitude and latitude, right, is not indicative of the Earth. I think that we have a problem separating what is the graticule, or what is graphed and projected into maps, separating that from the so-called physical Earth, right? I understand they're both not real and they're both concepts, but they're not the same thing. The spherical Earth is not the graticule. So, but with the basic takeaway is that since ancient times, the old astrolabe was stereographically projecting a spherical Earth onto a planar disk, and that's still what's happening with maps. They're really just projecting the spherical coordinate system tied to longitude and latitude, which is just inherently angles to the stars, onto a flat map. So all the distortions you see are based on that inherent sphericity and not because the Earth is a sphere. I think that's a good takeaway. If you can argue it successfully, then it negates the whole playing field, and you're not proving a globe, but you're certainly taking maps off the table as globe evidence.
Okay. And so based on everything we've discussed so far, what do you think is the best visual presentation that you brought with you to start off with?
Oh, I got tons of visuals, but I really want to do celestial theodolite, so we can get to that for her.
Okay,
There's a lot of visuals for that. Yeah, let's see here.
Lizbeth, you know about that probably more than me at this point, so go ahead.
Well, I'm still very much learning.
Oh,
They
yeah.
actually came into Flat Earth Gang today to further explain it. But I did watch the Globebusters episode with Dr. Mike Heffron, you know, Shane and Alan. And, you know, even after them coming into the room today and being able to further explain it, I find what's really fascinating is that we are completely taking refraction out of the equation. Like, refraction is not even something that's being accounted for. We are literally using the mountain peak as the crosshairs, as the thing that's blocking it. And what are we going to say? Oh, that the mountain's refracted. So it's like, no, you can't, you know, it's not an apparent object. It's a physical object. And if I'm not mistaken, Shane, you can use any mountain, any elevation, anywhere. And I think that that's the direction that this is going, is to get more of these observations and get more people involved to conduct these. And I've heard a few of the rebuttals, which one of them is that, oh, then it's coincidental, or, you know, trying to get Flat Earth to say then stellarium is wrong. So then the first question would be to ask on the globe side is like, do you trust stellarium? Do you, you know, is that something that you agree with? Because without being able to confirm that, then, you know, moving forward, the conversation may not go as well. I kind of saw that a little bit today in Flat Earth Gang, when it was kind of like, oh, well, you know, somebody had asked, a PhD actually had asked, well, what's stellarium? And we're like, oh boy, like, yeah, they were like, we can't go further than this, you know, until like we get that down. Cause then it was like, well, why can't we do the angle from the mountain peak and so forth? But I'm getting ahead of myself, because I know that we just want to break it down for the listeners and so forth. So please take it away.
Nice. So yeah, I have a couple of slides here. I think I've distilled it to a main, you know, visual argument. But good note that it's brought to us from our newest flat earther, right? Dr. Michael Heffron was joined us as a globe lad, hanging out in ether cosmology. I don't know, something we might have said, might have phrased it. Ended up declaring that it was he was a flat earther now, because of this specific observation, which he put together and then measured, and then measured, and then replicated, and then put together in a PDF. Let's see here. He also frames it in a scientific network. So real quick, the null hypothesis, right, is something for a PhD sort of framework, it's pretty much the best way I can explain it is as a flat earther, right? We like to take the position of falsifying the globe model without actually providing a complete coherent replacement model for most cases in most arguments, right? So like oh man, when crap, I looked at Alan's text, dude. Alan's fault right here. You just ruined my whole train of thought.
Ah,
Oh, hold on.
oh, no.
Okay.
What was I saying? Sorry.
I don't remember.
Null hypothesis.
So the framework from which you find
Oh,
Maybe he wants to explain it, or she.
yeah. Who's that? Who's your dog?
that's Levi, my border collie, who's super
Oh.
happy that his girlfriend is out.
Those are great dogs.
Do you want to take care of that while we cover for you?
No, that's fine. I think it'll calm down.
All
right. So like it's the framework from which you want to scientifically argue we're from a position of falsification, right? If we want to just falsify the globe model, the way you'd frame that is with the null hypothesis. So the way that Dr. Michael Heffron presented this to us was via null hypothesis, presenting, well, here I'm going to try to offer evidence to falsify this position, and if I can't, then what I'm left with is this position, right? So real quick, the basic premise is that we're using a conceptual celestial theodolite, right? So a celestial theodolite isn't a real instrument. It's a concept that he invented. He's going to use an optic device like a scope or a telescope or a theodolite, right? Well, whatever the scope is, that's going to be the first component. That's going to be what you're looking at, from this mountain over here to occlude a star. So the basic observation is from his position in his house, he can see which mountain is it called? Mount Pikes Peak. He can see Pikes Peak from his house, and Pikes Peak at a certain time occludes a known star. So what he did was, after he made the observation of the star being occluded, he did some flat Earth trig to predict the angle at which that star should be occluded. And we put it in a spreadsheet over here for everyone, I think. Oh, I had it.
There you go.
This one. There we go. Is that blank for you guys? That's blank, huh?
That's blank.
Oh,
That's
now
good.
there's text.
How about now? There you go. So there's the spreadsheet. A little bit smaller. Essentially, we're doing a flat Earth elevation angle prediction using basic trig, sine and cosine, for what this angle should be based on when you're going to move yourself to this peak. So that's the flat Earth trig. You can pretty much do a flat Earth plane assumption all the way through. So when we go back to, let's see here. Whoop. Ooh, she came back. All right. Sparking while laying down. He's not even really up. That's ridiculous.
That's all right. You're good.
I mean, the fact that he's barking while not even up, like he didn't even get up. He's laying down doing one of these half barks. What's that? So that slides back. But so the other part of our conceptual celestial theodolite, we got an optical device from a theodolite or a telescope that you're looking at the mountain with. The second part is the crosshair. We're going to use the mountain peak. It's going to be our crosshair when we're going to line up an observation of the sky. So when that star is going to be occluded, and then the final correction, the vertical crosshair, we're going to use stellarium. We're going to enter the long lat of the actual mountain peak that is occluding the star, so that we know when we look at from that mountain peak at that star, if that elevation angle of the star is occluded at the time that we make the observation, and then the angle at which it is occluded matches the flat Earth angle prediction. So what we've done here is essentially argue conceptually that we're taking this observation of a theodolite, right? We have our guy over here. We're looking at a mountain where it's occluding the star. When we use or employ the celestial theodolite, we're no longer using it over here. We're using this mountain as part of our theodolite. So it looks more like this, right? We're extending our whole looking device to the mountain, which is now part of our vertical, part of our horizontal crosshair. And we're going to know when this is occluded. So what that does is cut off all garbage from any observation of this angle, any difference between these two angles, refraction, bringing this up, refraction. All that's left is this mountain is occluding the star. So the crux of the argument is he's removed refraction from a celestial observation that has model exclusive prediction. So the other part of that is if it occludes at the correct angle, that is exclusively a flat Earth prediction. Therefore, we've nullified the globe, right? And then the only way they can argue against this is to try and put the observation back here and try and argue refraction, because if you put on refraction or if you account for refraction, then of course they can fix it. But what you would do is that they need refraction from the mountain to the observer, and then they need further refraction from the star to the mountain. So they need both half of this refraction correction to equal the angle. So by extending our crosshair to this mountain and by moving the observer in stellarium to the mountain to get an observation of the star, you're effectively removing refraction from the equation. And of course, you'd know the result is a flat Earth elevation angle. What Dr. Mike concluded from this was that all angles are at flat Earth elevation angles minus refraction. And that was the kind of realization that brought him over to us. That's a really quick kind of run through.
Nice. Nice. Very solid. What else you got? Hit us. Use everything in your tool belt.
Let's see.
Since you got the screen.
Yep. What else you want to look at? We got tides, big G, little G.
Oh yeah, and shout out to Nathan Thompson. He was saying you got great stuff on tides, as well as he had brought up the maps, which you touched on already. So what can you tell us about tides? Because I think that's one that we know on the globe side, we're told that the tides are due to the moon's gravitational pull on the Earth. However, they can't account for why aren't lakes and rivers being affected by the moon then if it's from gravitational pull. So what have you learned?
Oh, well, so Robert Bennett came to us with one of these observations from the tides. His original paper I stole from heavily and created this super long presentation on the tides. This was the first time that I actually met Jaron too, was to go through this giant presentation. Let me get this up real quick because definitely touch on tides. I said this is my other favorite thing to usually talk about is tides. So real quick, to go through the heliocentric version of what causes tides, right? As they say, it's the gravity of the sun and the moon. In reality, it's the proximity of the moon, right? The moon is pulling the tides. That's their method. So real quick, you know how everyone says there's a tidal bulge and they think that it's a hula hooping version of water? That's only true in this totally hypothetical theory of tidal forces called the equilibrium tidal theory. All of the tide comes from this equilibrium tidal theory. This is where the dynamic hoop comes into play. It ignores all sorts of mechanics. It ignores everything. It ignores ocean basins, predictable motion of the earth, winds, topography, all sorts of stuff. So it's a goofy theory, and that's why you get the only place that the tidal bulge exists was within this theory. The competing theory is the dynamic tidal theory. It's what incorporates amphidromic points, also known as tidal nodes, into the tidal variation. But to give it a real quick, their basic argument, right, is that gravity is using its force to control the tides based on, the gravitational constant and basic forces of gravitation. However, what they argue is that when the sun is next to the moon, a form of constructive gravitational interference happens, and that the moon's increased gravity to effect on the tides, and that's what you get spring and neap tides, right? So you get the total effect of the moon is really going to be when it's in phase. So the spring and neap tides aren't when the moon is close; it's when the moon is in its phase, either when it's new moon or full moon. That's what determines the highest high and the lowest low. Their argument for that is that it's next to the sun, and the sun's gravitational force is lending to the moon, and they get a positive gravitational interference. What that's called is tidal lunar acceleration. That's what they put when they do this gravitational analysis, and they get, the moon has a 2.1 tidal acceleration vector based on the sun. So the moon is 2.1 times more effective at controlling the tides than the sun. Robert Bennett's paper went into the physics of this a whole lot, and he concluded that geostatically, you can reduce all the action of the tides. When you compare the lunar tidal acceleration, he got, I think, 2.1 as well. Right, so 2.1 to 2.35, meaning that the tides can be totally explained just from the forces of the moon, and the sun has almost nothing to do with it. The math that he further went on to explain is that actually geokinetically, it is all from the moon, and that if it was true, then the comparison of the centrifugal and gravitational acceleration due to the sun would be 11,764 times more pronounced than it is. So that's if you take in the whole centrifugal force of the sun as it should be in the gravitational model to apply to the tides. That's the effect we should see, and we don't. But if you're going to ask what really causes the tides, right? It's is it really the moon moving the sun? I mean, there's no uniform path of motion here that would move the celestial bodies past it, where you could say that it was the proximity of that was causing the bulge, right? Their argue is that there's a solar and lunar tide in the hula hooping bulges of water, as we said before, and that would look nothing like this, right? This is real tidal motion. There is no moving a unified vector of motion that you would unify this, right? The tides are going all over the place. There is no proximity of a celestial body being caused. If I skip real quick to the good part, well, how do they actually predict tides? Is tidal harmonics and tidal constituents. They really just reduce the pattern of the sun to a sinusoidal wave, and they use basic data interpolation to predict when the next peaks and valleys will be, right? That's really it in a nutshell. The electromagnetic motion, oh wait, we had volume. As we know before, the electromagnetic argument for the moon then would be that it's moving, right? And that it's actually pulling, not with its gravitational force, but with its magnetic force. And of course, then you'd have more pronounced effect in salt water, because salt is diamagnetic versus fresh water, which is what you see with the tides in fresh lakes and oceans, right? So that's our basic argument for why it would affect it that way. What you really have, though, if you're looking at the high and low tides, right, is that there's a 90-degree offset from where the moon is to have the high tide. So if the moon is causing the tide as it circles around, why is the high tide over here if the moon's over here? And why is the corresponding low tide over here if the sun's over here? It's never exactly where you would see it if the cause was gravitational alignment of these celestial bodies. If that was the case, you'd be seeing it tug around the equilibrium hump. You'd see the water, right? Nobody sees that. We see it in a 90-degree offset. The speculation part, right, for replacing the dynamic theory of tides, if you want to speculate, is we have, an electric sun and a magnetic moon. And if you look at our dipole electromagnetic breakdown here from this flux map, it also forms sort of the same pattern. And when you have the moon sort of circling around, you have currents underneath it from the sun called telluric currents, which are geographically beneath the tides. They run through the earth. In the heliocentric model, they follow what's known as the solar wind. And that's so they're electric currents, not magnetic. The telluric currents are underneath the ocean and they're electric. Hold on one second. And then that kind of is what's causing the moon to have a delay, right? So I'm trying to explain the 90-degree offset of the tides. And if they're moving through electric currents under the sun, then there would be a lag time, as it would appear to chase the moon around with a lag if it's going through electric currents way underneath the ocean. But the driving force of tidal amplitude, right, is after all is said and done, right, what really controls the tides in reality when they're using the prediction, remember, the model that accommodates actual predictions is amphidromic points. That's these tidal nodes. Globebusters Tech did an excellent video on tides, I think 2 weeks ago. Everyone should check it out. When you map out sort of the amphidromic points, which are points of zero tidal amplitude in the world. These are points around which tidal amplitude oscillates. That just means that around this point, there is no change in tide. The highest high is offset from the lowest low, and they go around these points. So as this oscillates, the high tide's over here, low tide's over here, high tide over here, low tide over here. So what amphidromic points are points of zero tide around which tidal amplitude fluctuates. So if you're asking what really controls the tides, my answer would be these amphidromic points, these tidal nodes that are spread all over the world that nobody has any sort of explanation for, that nobody bothers to try to explain what's causing them and how the correlation is working to the theory. So when we talk about tidal amplitude, that's like, the highest high versus the lowest low. The biggest example over here in Australia, you have giant tidal amplitude swinging around all of the coast. And if gravity is causing that, you're going to have to show me the map, right? So the better example is that the tidal amplitude is controlled by these things called tidal nodes or amphidromic points that are spread around, that work with the actual amplitude of the sun. I think some of the video I have here at the end should probably put it all together to sort of wrap up amphidromic points, tidal nodes, ocean currents, gravitational forces, and the gravitational constant that we talked about. Let's see. Man, there's so many visuals. Let's see here. This one. Nope. There we go. So there we go. So we'll flash through all of them real quick. At the end, you got your regular sun and moon causing the the dynamic cause of all of our dynamic systems. Here's the actual ocean currents. Here's the heat map, right? Light over the tides. Here's the magnetic flux reading. Definitely the sun. Amphidromic points correlated to the path of the sun and the moon, the M2 tidal constituent in its tidal amplitude, magnetic flux lines for our quadrupole, the actual M2 tidal amplitude map again, tidal amplitude for M2 over in a different map, magnetic flux lined up again. Back to our heat map to sign overlay. That's overlaid with heat map and infodromic points. I was trying to find correlative aspects of tidal forces to say what, which aspects of our helmet was affecting. And what I got was like 17 overlays of different maps that I converted and was trying to just complete. But that's pretty much tides in a nutshell, unless you guys have follow-ups.
No, it's perfect. And again, overwhelming that the globe has real problems with tides, and ours looks far more elegant. I remember Rob Skiba when he was showing tides and everything above, everything from the jet stream to the tides below. It's always looked better on the AE map, always.
Yeah, so a lot of this, I spent a lot of time just looking at converting things. I'm like, look at this giant mess. Oh, look at this coherent circle. That makes way more sense. How about this giant mess?
Yeah.
Oh, look at this coherent circle. That makes way more sense. And then it's like, oh, how about this current? You know what? I bet that if I converted it, there it is again, right? Makes perfect sense over and over and over again. I found with every current, every map, even like the heat map, every tide thing. I mean, it all works way easier like this. It makes way more sense to me, right? So we have telluric currents overlaid with M2 constituents. We have, what's this? We have, cobalt thrust, mineral deposits. I had every map in here. I was going deep trying to figure out what tides were doing.
No, it's very interesting. We have a question from the chat. Kingdom in Context asks, do any of these tides run against the shorelines of Antarctica?
Yeah, so it's really hard to see, dude, but I think that the forces of the ocean via tsunamis are more indicative of that sort of effect. They seem to bounce off Antarctica and never wrap around, right? I think the argument is tsunamis and seismic waves wrap around Antarctica. So like the argument is that if it's a continent at the bottom, then it should wrap around completely. But what we get is a reverberation effect, right? It seems to rebound and come back. So more indicative of a heavy outer rim that, isn't a small continent at the bottom. I think that's what he was getting at.
Yeah, it is a lot more. I think that visual of how the sun or the moon, if it was moving over the earth, that those tides should be affected kind of in unison with the transit of those celestial bodies. But that's not what we see in reality or what we can measure based off of this data. Is that basically what you're saying?
Yeah, that was the beginning of my investigation. I was like, all right, so if you're telling me that this celestial body is pulling the water around it in a tidal hump, as you described, as Neil deGrasse Tyson said, it hula hoops through, right? If that's happening, then that should be evident in the actual tidal patterns. You should see proximity burps and gurgles or whatever as it followed the moon around. You wouldn't see a completely offset diagram of it doing the same, right? You wouldn't see, oh wait, that's elevation for Antarctica. You wouldn't see it doing what it's doing. You wouldn't see it complete irrelevant, right? So there is no unified vector of motion that would describe the tides. The better explanation is that we have all these amphidromic points all over the world that are around which tidal amplitude is oscillating. So the biggest high tides and the lowest tides are around these points. And the prevailing theory is nobody knows what they are. Nobody knows if they're whirlpools, where they are, if they're on land, they're under ocean, they're all over the world. Nobody has any real understanding dynamically of what they are or how they do what they do. And the globe model just says, it's probably Coriolis.
Huh. Yeah, no, it's great. See, just more things that make you go, right? When you get to the flat side. What else do you got? What do you think that is a big one that comes to your mind, Shane, that you're just excited about that the globe side likes to say is a flat earth death blow? Is there anything that we haven't touched on yet that you think is
the sky, man? They say it all the time, right? Like, look at the sky, you globe, right? You didn't know that? Globe, it's globe, dude. I mean, the sky is their big win. But I think that's what I like. I concentrate on the sky a lot. I do lots of modeling, right? So the celestial phenomenon is pretty much all modeled in that Shane's model program, but it's based on flat earth elevation angles, and it wraps a hemisphere around the observer, and only then can you emulate true flat earth elevation angles for all over the earth for all celestial observations. But my main premise, right, is that they took the celestial sphere, which is a mathematical contrivance based upon an observed hemisphere of stars in a flat plane, and from this model, they've filled out the bottom using spherical trig, and an assumption of a circumference. So they just said, hey, when you don't see it, it's beneath your feet. I can use math to predict when it comes back around. That's fine. From this conceptual model, they created this conceptual model, and then their whole trick was they just swapped it out for us, right? No one was looking. Boom, one's the other. There you go. Right. So like, the whole trick is that no one knows the globe is actually the celestial field modeled out, and that they tricked everyone with maps.
Yeah,
Well
so
done.
interesting. A lot of
Solid
people don't
pop
take
culture
into,
reference, by the way. Go
yeah,
ahead.
that was very cool. Loved that movie growing up. But a lot of people don't take into consideration, especially if you're on the globe side, a lot of these things just never even pop into your mind. But it's your own field of vision has a lot to do with how we observe this reality. And it, like you guys were saying, it's different for everyone, but yet it works individually. It's a little bit of a hard concept to fully grasp your head around until you kind of attribute things that the science side would say, no, that's the fine tuning of the universe that they can't explain. But then you get to the flat side and it's like, oh, that's where definitely intelligent design can be invoked, because how else is it working so beautifully?
Well, I mean, like, so when they say how else could it be described, this is what I keep coming back to, right? If you just observe the sky, you would come to the conclusion that if you don't see the whole sky logically, then you would see a portion of the sky. And if you have a limit to your vision, which we've just concluded because we don't see all the sky, and if that limit was extended the same in every direction, it would invariably form the shape around the observer, right? So this is how you see the sky. The celestial heavens, it's always in the shape of a dome. It doesn't matter what model you think you live on, empirically, observably, from within this dome, it looks identical. Whether you're on an observably flat plane that has a hemispherical view, or whether you're on a sphere that's curving so little that it's treated like a flat plane up to 600 miles and observing the same celestial heaven, it doesn't matter. You're making the same observations. You're just interpreting the observations differently, right? So that whole argument is like, this is how you see the sky. The Glober argument is that everything in the world obeys the law of perspective, like tall buildings, street lights, mountains. Everything recedes into the distance along with perspective in a proportionate rate that has to do with perspective. Everything except the stars in the sky, which do the exact same thing at the same rate, but for a completely different reason. And so the actual steelman of the Glober position is that perspective affects everything except the sky. And perspective, the only reason the sky looks like that is because of curvature. The Earth is curved. That's why everything rotates in the sky. So that's the key difference in the position. Otherwise, we all observe the celestial objects like this, right? If you see a star, you see that it moves this way, 69 miles per degree as you precess laterally along this plane. The stars appear to precess upwards, right? That's just what it looks like. All of our modeling programs emulate this. All of the observable that we can, this observable phenomenon is repeatable by everyone. Every conceptual model uses it the same way, right? If you look at this model, this is actually a globe model, which is just a flat plane with a hemisphere observer. This is from a university that we nabbed. This is modeling the sky. So I think the biggest takeaway is the globe was made from this and this alone. A dude on a flat plane with his hemisphere of limited viewability. And as they move around, the stars move differently. You get different constellations in the north and the south. You get latitude dependence for these observations. From that latitude dependence, they literally contrived and created the globe model.
And that also plays into star trails. Is that correct?
Yep, that is star trails. Let's see. We can do the model real quick for that, I think. That's a good demonstration.
Because that's the globe side's argument of like, look at the star trails, but they're not taking into consideration this personal sphere of dome that is based on your vision, right? So that's why something can appear to be going one direction when it's really going an opposite direction. It's the most simplest way I could say that, but maybe you can help us kind of elaborate.
Yeah, so this perspective-induced counter rotation here, I'm going to reshare with this. There we go. Cool. So you guys had Stephen Alonso on. He did a different model with actual multiple observers, and he put actual celestial coordinates in here, which is way better. But the basic premise for stars would be that if you have a limit of observability, right? If you have a limit to your vision, which we know because not everyone can see all of the sky, then let's say this limit of vision is half of the globe, which we say as a sphere, you see in a sphere radius 3959, right? Give the globe some credit. Assume that all of the observations of antiquity, the way that they built the model makes sense. Let's give them the credit that maybe we see about this much of the sky, right? They made half of the sky visible on a globe with a spherical circumference. We make half of the sky visible by only seeing half the sky, right? So as you would observe the stars, right, from here, they would appear to spin around you. Do I not have the stars on? I don't. They would appear to spin around you. Let's do this. All right.
Oh yeah, start over. So
yeah.
tell us what's going on here. The stars are moving which direction?
So yeah, this would be what, counterclockwise to the observer within the northern hemisphere, but they're going in the same way as all the other celestial phenomenon. But if you were to stand underneath the North Pole, you would see it rotate like this, right? All the stars would rotate around you in this hemispherical view. Now, because of that,
let's break it down just a little, just go like a pace slower, just in case somebody's having a hard time following along. The person that's observing is in that smaller dome. That's correct, right?
yes. So like this is your observer, right? And this smaller dome is only meant to show you the limit that we went on before, the limit of your vision, how much of the sky you can see. And because it has a limit, the part you can't see, things appear to rise and set in this limit. Right? So as they appear to rise and set, you see them kind of come up on the ground and descend. So that's the basic premise there.
And do the constellations shift as well? Because someone in the chat, oh, it's actually Karen B. How come we only see Orion half the year?
Orion,
Which I've observed that for myself. Like I know in the fall that I'm going to be able to see the constellation Orion, and then it starts when it gets closer to spring and summer, I can no longer see it. So what's happening up in the sky that creates that?
Well, what do you mean you can't see half the sky? Because that's latitude dependent, right? You can see as much of the sky as you can from your latitude everywhere on that latitude.
But if the constellations they're shifting, are they doing 1 degree each day for a 365 for the year? Is that something that we're kind of not taking into consideration maybe?
Well, so the visibility of constellation is like, so they have northern and southern constellations, but the zodiac constellations are in the middle, right? They're pretty much this band of the tropics. That's what they occupy. So they should be visible to everyone at some point in the year. Now they do kind of migrate, and for half of the year you lose them, but because they're in this main band, everyone over Earth can see most of the zodiac, right? That's why it's special. That's why all the ancient philosophy build their pyramids to it, right?
That migration, that's what I'm trying to get at. How can we visualize that with your model? Is there a way to show us?
I made a different visualization with some maps on it, actually, where I moved just the celestial sphere aspect of it. I think I have a video.
Oh, Nathan Reed saying it's only due to the daylight. That's interesting. Okay. So when we have summertime versus wintertime, we're seeing different things. I mean, this has always interested me personally, just why we see certain constellations at different points in the year.
Right. So the sun moves the same speed as the stars, almost -4 minutes, right? You got solar speed and sidereal speed. And because of that, some of the constellations travel with the sun, and the sun will slowly move out of constellations to other constellations throughout the year. I think that's what causes people to see less of the constellations, right? Sometimes they're in the daylight.
Interesting. Okay.
But as far as the stars go, right, real quickly, if you see in a sphere of limited radius, then from the center, they would look like this. Let's put the stars on, actually.
And see, what I'm gathering from this is that the globe side is saying this is all just happens to be a perfect accident that's so consistent and they're reliable, so they can make their predictions off of it because it just continues to repeat itself. Where if we really were a rock in space, we would have different constellations at different times in history. We would have stars doing parallax, all sorts of different things that we don't really observe because it's so consistent. That's where this model, for people who are visual, can really see that it's super intricate, the system here. And reverse engineering it based off our little observer is it's pretty amazing, because obviously it's hard to figure out until you get into this side of things, when you start to question what we've been told. It
should be a giant spaghetti monster in the sky, and a different one at that every single night, right? That's the takeaway. The dynamically, if everything, all the motions are true, then we should be seeing all different stars. But they're like, no, they're so far away that somehow none of that matters. And what you see is perfect ellipticity and concurrent circles forever in perpetuity. Like, yeah, nice, cool story, bro, or whatever. Like, that's amazing.
Right.
But like, so if the star argument then is that from the North Pole, you would see everything rotate around Polaris. If you move halfway to the equator, you would see the center of rotation shift to go to 45 degrees. You would then see all of the stars rotate around that. What you would see here, I have to call this the celestial arc, right? This is what the globe model is based on. It's the apparent motion of the stars, which are moving around your center focal point in the center. The next point would be if you go to the equator, you get equatorial star trails. So they're in perfect line as they rise and set, right? And as only at the equator do you start to see the south celestial pole, which is an optics-induced convergence, right? So it's sort of a hard one to explain, but this is the nighttime component of what you would see during the day with crepuscular and anti-crepuscular rays. So even in their model, the sun puts out perfect parallel light rays, but somehow if you see crepuscular rays from the sun on the horizon, if you look behind you on the opposing horizon, you'll see converging anti-crepuscular rays, which will converge on a point where the sun is not. And that's your perspective, putting what is effectively parallel rays around you. So it's a evidence for seeing in spherical vision. And at nighttime, you get this counter convergence point in the south while looking south. Now, the motion is still going the same way. If you're looking north, you got counterclockwise. Now, if you move a little bit more south from this point, then you lose the actual source of rotation, and then you look south. And from south, looking south, they appear to go clockwise, right? The example here is it's just an aspect of your perspective and the same motion. So if you took a paper towel roll, right, and you looked at it next to under your nose and you had spikes on it and you started rolling it, if you looked left, it would be going clockwise. And if you looked right while maintaining motion, it'd be going counterclockwise. So the same motion, your perspective is putting in two different counter motions, right? And the same thing is happening here at the equator while looking south. And so the south celestial pole is really just an optical convergence, be latitude dependent, around which stars appear to rotate, right? And it only appears because of the limit of your vision and because you're so far away from the center that you can only see what is, in effect, the anti-crepuscular effect. What do you guys think?
I just need a download from you to my brain. Are we at that point of the Matrix? I love this. You're doing awesome, man. Thank you so much for just really taking the time. I feel like we're going to have you back for a part 2 in the future, and we can get more questions and things from our viewers. But I guess because we have a little bit more time left, maybe for one thing. Earlier in the program, you had said that someone had bet you to make a prediction. Is that the software that you used to make a prediction about the eclipses? What would you say to the globe argument that the flat side can't make predictions?
Well, so the actual argument is that there are no eclipse predictions, right? It's permanent cycles in the sky. As we started to say, if you trace back those cycles, you get the age of the Earth. But so is it really a prediction if you know when and where everyone will ever happen, right? That's back to kinematics and empiricism versus, look, if the sun sets tomorrow, like I know where it'll be. So, I mean, the real model, the real point is that nobody predicts it. It's all based on cycles. But because nobody wants to hear that, I started pretending to use Flurf magic and a wizard cap to predict eclipses on the internet. Lo and behold, so I got a couple bites, and they were like, "You can't predict it," and I was like, "Behold, watch me dispense Flurf magic and wave a wand, and I'm going to make a prediction." That was the framework in which I did, because first I was like, "Nobody predicts it; it cycles." They were like, "No, we predict it. You're stupid." And I was like, "Okay, hold my beer. Watch this thing."
That's really important that I think our viewers take away. It's like, because of the fine tuning of our reality, whether it's a globe or flat, that's what they're calling our predictions, but it's the cycles that are reliable. And so those are what is being bundled as that the flat side doesn't have on their side, when in reality, the globe side has taken reality and they've worked around it to create deception. Sorry.
There's an argument there, like, of intent. Like, are people unknowingly duped and perpetuating the system? People like who work with GPS may only given a spherical coordinate system, do the calculations, do the work, output in spherical coordinate system. I think there's something to be made for a Truman Show joke. We accept the coordinate system with which we're presented, right? So if you're doing all your work based on GPS along that, you wouldn't know or think there's anything else but it. So I mean,
well, that's why it's so important that when you come to the flat side, it's like, again, the floor is important. It's not everything about this house that we live in. It's the location. Where is the Earth? And if the Earth isn't rotating around the sun, then what is going on here? Because then you have lights in the sky moving above us. And I just would encourage our viewers to continue to trust their senses, that when they look up, they see for themselves that the sun and the moon are moving above us, and that there are many explanations that you can dive deeper in if people haven't done that yet on the flat side. That Shane, obviously you spend a lot of time researching and trying to understand because you see the importance. And that's why people like you are invaluable in this community, which again, people can come and go as they please. It's not about being stuck in a belief system. This is talking about that the world we live in is a created, designed, beautiful realm, and that it is easy to call it predictions when you know the cycle.
That's the trick, right? They go and like people just say NASA predicts eclipses. Like not only do they not, they farm it out to Fred. Fred predicts eclipses if anyone does, right? But Fred uses the cycles from the Antikythera era and the old school Lubin and Saros cycles. So
Wow.
all
Well,
flat Earth.
awesome job. You really impressed me today. Thank you so much for being here.
Fantastic, Shane. Do you have any parting words before we tie a bow on this show?
Thank you for having me on. It's been fun, dude. And Mark, I hope you don't remember that 2 years ago we already had a talk. I know you don't remember.
No. Actually, believe it or not, I do remember. But if you remember the episode, please shoot it to me and I'll review it.
I remember that I was impressed that I was on your big channel. I remember that, so it's probably out there.
And again, happy to do it, and I'm glad that it came back around, and here we are. So that's awesome.
Excellent.